Welcome to Modern Manufacturing 2020. We're super excited that you all are here. My name is Maddie. I'm a recruitment specialist here at ECTC. Just a quick note before we really get rolling, make sure that if you're watching from an individual computer that you are logged into your Google account, so that way you can comment and interact. So while we give you a few minutes to do that, and give a few minutes for others to hop on, go ahead and drop in the comments maybe where you're watching from or what you're interested in, maybe what you're most excited to hear about today. Like I said, we're super stoked that you're here. Also, throughout our time together, if you have any questions, comments, concerns, anything like that, go ahead and drop those in the comments as well. I've got Emmy off camera helping me run all the technical side of everything. If you joined any of our Facebook Lives this summer, you know how awesome Emmy is, so just go ahead and drop those in the comments. We're going to be monitoring those throughout as well as I'm monitoring them right here. So go ahead and drop in the comments where you're watching from, any questions maybe that you have right off the bat, and we'll go ahead and get started and kind of talk about some modern manufacturing. It looks like some of you are actually already on, so we're just going to get rolling here. So we're really excited to talk about advanced manufacturing today, and you're going to see lots of things from the manufacturing process, things that you would actually see out in industry. And the manufacturing process usually starts with like a challenge or a problem that's been identified, and then those in the manufacturing industry actually work to create a product that will help meet that need or solve that problem. During our time together today, we're going to see several different demonstrations by ECTC instructors using innovative technology right here on campus in our lab spaces and classrooms that you might find in the industry. And among the things that you might consider today in our time together about advanced manufacturing, or about what it may look like to choose a career path, or maybe even changing career paths. Some of those things you might think about is A, job security, B, availability, and C, salary. And so our instructors are actually going to talk about some of that stuff today. But first, let's talk a little bit about advanced manufacturing and put some of that into context for those of us who may not be super familiar with the field and what all that entails. Advanced manufacturing is the use of innovative technologies to produce products or to solve problems. It is a growing field with careers in all sorts of areas like automotive, aerospace, food and beverage, medical, and so much more. Emmy went ahead and put up this slide for me. Here are some of the employers in our region that you might recognize. Some of those employers are Altec, which produces bucket trucks, Inuac or TG Kentucky and Toyotomi that are automotive suppliers, and Midpark that produces structures for things like highway signs and overpasses. And again, these are just a sampling of the many right here in our region, and actually in your hometown and maybe some of your backyards. So if you're technically inclined, you've got an interest in STEM subjects, or you just really like hands-on work, advanced manufacturing may be something that you consider. You might be interested to know that Kentucky is third in the U.S. for automotive production, as automotive is the state's top manufacturing sector. Just last year, actually, Kentucky exports totaled $31.36 billion, and our Commonwealth is home to over 4,500 manufacturing facilities. That's crazy. Now, the average annual compensation in manufacturing, we're talking about salary here, in 2018 was $72,614, and Kentucky manufacturers employ more than 18% of the workforce. If these numbers aren't enough to really pique your interest in the field, CreatorsWanted.org estimate over the next decade that 4.6 million manufacturing jobs will actually need to be filled in the U.S. Okay, so you're probably tired of listening to me talk already. Let's go ahead and jump over to Brent in our CAD lab, who's been working on a project. I'm super excited about this. We'll check in with him actually a few times throughout our time together, because you all are going to actually get to guess what he's producing, and you'll find that out before it's finished. Also, just as a disclaimer, some of these clips and video things that you're going to see today were actually filmed pre-COVID, but we are currently following all of the Healthy at ECTC guidelines. So let's go ahead and jump over to Brent.
Hello, my name is Brent DOTY, and I'm the program coordinator for computer-aided drafting and design. Basically what we do here is we solve problems. And actually I have something up here on the computer that I've been working on to solve a problem for myself. But what my students do is, we work on projects and different assignments, and the whole idea is to give them some kind of a whether it's create a model or create drawings that other programs could use, like CMM. They can make the parts that we actually create. So we work with all the other trades and other areas to solve a problem, and they're the ones that actually end up doing the fixing sometimes and completing the job. We're getting ready to print the part that I've got up here on the screen, and when you come back, we'll see how it's doing.
All right, thanks, Brent. That is super awesome. I'm really excited for you guys to see what he is producing. If you think you have a guess or you think you might know what he's making, go ahead and drop that in the comments as well. That would be really cool if one of you actually guessed it. So if you think you know what he's making, go ahead and drop that in the comments and we'll be looking at those. It looks like we don't have any questions at this point, but don't be afraid to drop those questions or comments there. We'll keep monitoring that and make some time to answer those as we go along. But we're actually going to go ahead and move into our first full demonstration. And I'm really excited about this demonstration. I got to sit down with our computerized manufacturing and machining program coordinator, Grant Logston, and actually one of his students. So let's go ahead and take a look at some of the hands-on experience that his students and those in his classrooms are getting as they prepare for careers in advanced manufacturing. Hey, so Grant has an EDM demonstration set up for us in the machine shop. Let's go check it out, but safety first.
My name is Grant Logston. I'm program coordinator of the computerized manufacturing and machining program at ECTC. I think it's a great field to pursue because if you're a student that likes to work with your hands, you like making things, you like taking things apart, putting things together, it's just a great field because we run all kind of different machines, and it's just a great field. We're going to use a wire EDM. It's an electrical discharge machine, a very high-tech machine, and we're going to cut out a 36-tooth spur gear that's actually going to be used on one of our other machines. The work here begins on the computer with Mastercam software. Our students will draw the part, assign a toolpath, generate the code, and then load it on a flash drive that will be uploaded to the machine. After the program is loaded, the EDM, which is an electrical discharge machine, uses 10 thousandths brass wire to cut out a precision part that will actually be used on another machine here in the shop. You can use any material as long as it's electrically conductive, but here we're cutting a gear out of aluminum. The brass wire comes into close contact with the work but never touches it. As the machining begins, 30 to 40,000 sparks per second will jump from the wire to the workpiece, exploding a path for the wire to follow. The wire follows the path with extreme accuracy to cut out the profile of the part. These machines are incredibly accurate and it takes extreme precision. The EDM can cut materials within 0.2 of a thousandths accuracy. That's like taking a sheet of paper and slicing it thinner 20 times. An EDM and machines like it are used to make parts for aircraft, tool and die parts in automotive manufacturing, for surgical equipment in the medical field, and just about anywhere there's a need for extremely accurate parts.
Hi, my name is Holden. I graduated from Laredo County High School. I'm a student at Elizabethtown Community and Technical College. I'm now working at Atlas as an apprentice, and I'm hoping within a year I can get up to $80,000 a year. And ECTC has helped me get there. What I love most about my job is that I get to be hands-on. We have big equipment that we work on for Toyota, the government, a lot of different companies that need giant stuff made, such as a gear that's 16 feet diameter. And it's nice seeing that we can make a difference in the industry.
I think the cool thing is some of the machines that we have are just absolutely fascinating. We'll use a computer to program something. We'll load it onto a flash drive, put it in a machine, set the machine up, hit start, and we come out with a finished product. And it is an amazing process.
All right, welcome back. I just think that's really, really cool. And it really blows my mind just how like precise everything has to be, and how precise that those machines are. That's one of the things that I was really interested in learning about advanced manufacturing, was that it's not the large clunky machines in a dark, dirty basement anymore, which is, I think, what it's often misunderstood to be. But they really are intricate and they require a great expertise. We're getting ready to go check back in with Brent. I'm not sure if some of you are having trouble commenting or something like that, but just know that we're here, we're monitoring those. And if you have any questions or comments or concerns, even after this video, feel free to email me. We'll talk about some of that contact info before we leave today. But let's go ahead and check back in with Brent in the CAD lab and see how things are going with his project.
Welcome back to CAD. Right now we're working on the printing process. I showed you how the creation process went, and now we're working on the actual making of the part. And we're using some filament here. This is a black color, it's a PLA. There's some other materials that we can use. And this is actually what we call additive manufacturing. It's similar to CMM, except it's the opposite, where they do subtractive and they start out with a block of material. And we just start out with this material here, and it actually creates it. So this part takes about an hour to print. Some take longer, some are shorter, just depends. But we'll check back here in a little bit and see how it looks. Welding or welding.
All right, super cool. So welcome back. We have seen the beginning part of that process where it started on the computer with the drafting and designing, and then you just got a look into the actual making part, creating part of that process with Brent. But did you catch the little tidbit about additive and subtractive manufacturing? I think it's really exciting that people in the industry solve problems different ways, and maybe their brains work a little bit differently, and so they really are problem solving from different angles and methods and perspectives. Sorry, that word is hard, but perspectives. But we're actually getting ready to go to our next stop. Hey, so I'm in the electrical technology lab with Tim, and he's got a really cool demonstration set up for us, so let's go check it out.
My name's Timothy Cordova. I'm a professor here in electrical technology. I've been doing this for 18 years. So manufacturing, there was a time where we were shipping a lot of things overseas. I think America's realized that the best stuff's made right here in the United States. So I see manufacturing as sticking around for a long time. I also see the rise of robots. Robots are going to be used. They're going to be used in our homes. They're going to be used in industry to clean things when we're gone, so there's going to be a need for people who know how to repair those items. So today we're going to be demonstrating an industrial motor controls 2 pick and place that utilizes pneumatics. It's got a photo eye sensor on it. It's computer controlled by a programmable logic controller, and you'll see it use the pneumatics to pick and place a puck off of a conveyor system. So on this machine, this student used a personal computer to create a program that's downloaded into an industrial computer called the PLC. PLC is the brain for this process, as it controls all of the functions on the components. It works hand in hand with the variable frequency drive to control the speed of the conveyor and the dispensing of the pucks, and basically how quickly everything functions. This is important because when this skill is used practically in an industrial line on a much larger scale, everything has to be timed precisely down to milliseconds and even faster. This system uses a photo eye which senses the color of the puck compared to the conveyor belt. The conveyor belt is black, the puck is white. When it sees that contrast, it triggers a sequence of events, including the pneumatics to direct the airflow to engage the slide to pick the puck up using vacuum pressure. To put this in perspective, you replace the puck with a bottle cap, and your robotic system is now assembling bottles of bourbon, Coke, you name it, even ski. So robotic technicians make generally about $65,000 a year, and that's without overtime. So when you think about overtime, think about an extra $30,000 to $40,000 a year depending on that overtime. We also have process control technicians. When you think process control, I like to think about distilleries. I think it's most cool really because when you think about the future, I keep thinking about how it's changed. So from when I started to where it is now, when I started, no robots, now robots everywhere. That's pretty exciting. And when you think about the pay that's going to keep going up and up and up with somebody who needs to know the skills necessary to work on those things, I think that's what's the most exciting.
All right, thanks, Tim. That was a really fun day getting to sit down with Tim and talking about the future of advanced manufacturing and watching him dream a little bit. That was really cool. I was excited to do that. So you can see that this field is not only changing and growing rapidly, but it really is one with job security and staying power, which is really important as our world is continuing to change. So that really may be something that you think about. And another thing that you may have noticed in these demonstrations is just the diversity of our students in the field. For example, more and more women are finding great careers in manufacturing, and our instructors would tell you that there's nothing a woman can't do in this field. Let's check back into the comments. It doesn't look like we have a whole lot of you chatting it up, but I know that you're watching, and that's really exciting. So let's go ahead and take a last look with Brent in the CAD lab to see that finished product.
Welcome back to CAD, and this is our last installment. And you're probably wondering what I was making. Well, I'll show you. It was actually a buckle for my backpack to help keep this strap from moving. I don't know if it's going to completely fix the problem, but at least I'm on the right track. Basically, the way the CAD program works is you start out by doing some hand sketches, some hand drawings on a board similar to what I'm sitting at right here. And then they move on to the computer and they start doing the same thing but on the computer. And they move from 2D drawings into 3D drawings and making the models. And then you can either go to 3D printing, you can create the drawings that the other areas use, like CMM or electrical. We work with them to create drawings that they read. We'll create the actual drawings for the solving of the problem, whether we're doing the solving or somebody else is. Most of the jobs are set up as a designer type job. They might be called CAD operator, CAD designer, or just designer. And you can be mechanical or architectural. Usually they make somewhere between $15 to $20 starting off, and you know, it could be more. It really depends on your skill set. Well, the real reason that I like it is because it's cool to solve problems. I have a lot of students that they enjoy making things, not just 3D printing things, but actually designing something that they can say, hey, I did that. You know, like if you designed a house and you can see it built and then you're like, hey, I drew that. That's what CAD's all about, solving problems.
All right, so it was a buckle. If you guessed buckle, then you were right. If you didn't, sorry, it was a buckle. So I love that he actually mentioned that he wasn't sure if his design and his buckle was going to actually fix the problem, but at least it would be a really good start. A lot of problem solving, as I'm sure you know, is trial and error, but he's really working to achieve that goal. And with the technology that we have available, there's really not any problem that you can't solve. Brent actually put his problem solving skills to the test and to use earlier this year when all of the pandemic started, and we had healthcare professionals that needed face shields, but there was a shortage. And so in the CAD lab, he actually designed the plastic piece that fits right here on your forehead and attaches the shield, the face shield, to that plastic piece. And he produced hundreds of those and gave those out to people in the community. And so he was really helping out our healthcare professionals. So way to go, Brent. That's super exciting. We have one more stop. Are you ready? Whew. So we're here outside the robotics lab with the engineering and electronics technology program. Marty has a pretty cool demonstration set up for us, so let's go check it out.
I am Marty Sutherland, and I'm a professor here in the Engineering Electronics Technology group. Today we're going to watch a FANUC robot simulate a weld demonstration. What you see here is a FANUC welding robot. We're lucky enough to have 5 small pick-and-place robots and this large welding robot that you would see in the local industry. Our students get first-hand experience programming these robots and running complex programs you'd see in local manufacturing. Now what I've done to set up this demonstration is use a teach pendant, the little computer I'm holding, to develop a number of steps for the robot to follow. So it follows an X, Y, and Z axis, which means that it can move up and down and side to side and even rotate. It's really satisfying to see a program developed on a computer and then translated to this powerful yet delicate machine. You might notice the small weld wire that's barely touching the steel part. We're only simulating the welding part of this demonstration just for visibility purposes. The smoke and sparks make it real hard to see up close. Our students, they get to develop this from the ground up. It's up to them to code, troubleshoot, and perfect different scenarios you'd see in the advanced manufacturing industry. Some of the career pathways that you can get into, we've got things like robotics and automation, which would get you over at Matassa, AGC, or some of the places. We've got instrumentation process control, which would be chemical plants like Dow Corning, or water treatment plants, or maybe some of the distilleries. We also have the electronics, which goes into like Raytheon, or maybe even LG and EKU in Louisville as well. Those are some of the places you could go. Now some of the salaries are starting usually around $52,000 a year. With a little bit of experience in a couple, 3 years, most guys are making upwards of 100 or over 100,000 a year. When I talk to my former graduates, the main thing that they say they love about their new job is the pay. They really like that high salary. They can provide for their family, they live comfortably, they can do the things they want to do now. They like the challenges, it's something different every day for them to go to work. They really enjoy it.
All right, I'm not really sure how familiar you are with robotics, but I'm really amazed at how students are learning to program those, to do different tasks and functions, anywhere from welding to cleaning to pick and place functions. Marty and our other instructors really hit on one of the biggest draws for advanced manufacturing field, which is pay. While it's certainly not the biggest factor in what makes this field enticing, it really is a consideration. Our instructors spouted out a few salary figures anywhere from $40,000 to $65,000 to even 6 figures. But what does that really mean? So let's put money into perspective. The median household income for Kentucky is about $48,000 a year. And we do know that a lot of those households even have 2 incomes. So with a career in manufacturing, you could be providing for your household above the median income in Kentucky. Now, advanced manufacturing isn't only the program that you've seen today, that you've seen today, which are computerized manufacturing and machining, electrical technology, computer-aided drafting and design, and engineering and electronics technology, but also welding technology, one of the most highly paid of the skilled trades, and industrial maintenance technology, where you learn to install, repair, and maintain the machinery and systems that keep industry moving. All of these are 2-year degree programs here at ECTC with the options for diplomas or certificates that can be completed in a shorter amount of time. If you think that you want to get a bachelor's degree, you can actually follow some of the tracks within these programs to transfer into another college or university. And if you're thinking of something like engineering, make sure that you check out options for knocking out your general education classes at half the cost. Our Associate of Science degree can be completed with electives in any of these programs to set you up for a bachelor's degree that will lead you into the manufacturing workplace. So if you're ready to find out some more information about anything that we've talked about today, or really find out more about your options, you can visit our website at elizabethtown.kctcs.edu. And there you'll find information on all of our programs, our scholarships, and the application process. And if you need any help along the way, please don't hesitate to email me and us in the recruitment department at ectcrecruitment@kctcs.edu. Thank you so much for joining us today. It's been a lot of fun hanging out with you.